In this step, we will demonstrate the identity provider powered by TNO, which authenticates the connectors and other components deployed in the EU Hubs for Data Federation. The prerequisite for the DIHs in the EU Hubs for Data Federation to securely exchange data is an identity provider trusted by all, which is established through a transparent certification process for all participants. Each participant organization in the EU Hubs for Data registers its own identity and is issued a certificate attached to this identity. Similarly, each connector in the data space has a separate identity, which is linked to a participant and for which a certificate is issued. The certification is a dynamic attribute, meaning that when the certification level of a component changes, there is no need to issue a new certificate. Each component used in this demo uses its own identity for identification and authentication purposes when communicating between each other. A new X509 identity certificate can be requested via a simple form that leverages OpenSSL commands to generate the certificate signing request used widely in the industry. This way, participants can create new certificates to be used in the data space. In this step, we'll demonstrate how ITI uses an IDS connector to publish a dataset and how then it makes it available to the entire EU Hubs for Data Federation using the Catalogue Manager. This is the OpenAPI specification of the Dataspace Connector version 6.5 shown using its Swagger UI. Through this connector, we're going to share an IRIS dataset with the rest of the EU Hubs for Data Federation. Using the endpoints under the offered resources section, we can use a GET request to list the currently offered resources by this connector. As you can see here, for each dataset offered by the connector, a URL is returned that members of the Federation can use to access the resources contained in the dataset. If we want to share the dataset with the EU Hubs for Data Federation, we have to publish it in the Catalogue Manager, also known as the Service Delivery Framework. And this is the web interface of the local version of the federated catalog. Right now, there is only one sample dataset published in the local catalog, which is not being shared with the Federation. As you can see here under My Assets, it has not been published, which means it's only in our local instance of the Catalogue Manager, and it's visible. The visibility toggle is used by instance owners to decide which datasets to make available at any given moment. The enable toggle is not yet implemented. It will be used as an administrative tool in the future. So we're going to share an IRIS dataset with the rest of the EU Hubs for Data Federation, which will be a single dataset with, let's say, no license, contains no personal data. It's in the domain of the environment, and it covers the whole of the EU. One of the most important details when sharing an asset is the link or links where the resources of the specific dataset can be found. We are going to use the link to our connector's offered resources from the earlier step and add it to the metadata of the dataset. We should also add, for the benefit of the consumers, some description, which we're not going to bother with right now, and details about the format and the language. If we save the dataset, we can see that it has been added to our local catalog, but it's not yet being shared. If we go back to the datasets view, nothing has changed. This is because
the new dataset is neither visible nor published. If we toggle the visibility option, we share the dataset, but only in the local catalog. Finally, if we want to share the dataset with the entire federation, we toggle the publish option, which causes that in the global catalog view, the dataset will have a propagated tag confirming that it is now being shared with the EUH4D Federation. It will show up in the global catalog, and any other member of the federation can consume data from it.
In this step, we'll demonstrate how EGI uses the Catalogue Manager to discover datasets published by other DIHs in the global EUH4D catalog and how it can download data from one of them.
On the local machine, we are running two logical components. One is the Catalogue Manager, also known as the Service Delivery Framework. I'll demonstrate its web interface in a second. And the other one is the proof of concept EGI developed for EUH4D to publish data from EGI Data Hub into or using a IDS connector. This is made up of three containers. One is the connector itself. One is a specialized UI for the connector in case you don't want to interact with the connector using its Swagger UI. And the third one is the component that actually publishes files from the EGI storage into the local IDS connector. And now the user interface is for them. You already seen this. This is the Catalogue Manager. As you can see, it synchronizes some datasets from the global catalog. These are labeled as federated asset, but there is also a local dataset. This is the dataset being published from using the local IDS connector with data from the EGI Data Hub. Now, this is the Swagger UI of the connector, which we won't be using. Instead, we will be using this specialized UI for the connector. As you can see, we are running connector version 7.1, which speaks all these info module versions, and it's configured to speak 4.2.6, which is not the latest version, outbound. This is necessary to be able to consume data from older version connectors, like 6.5 used by ITI. Now, if we switch to the dataset synchronized from the global catalog, we will see that in the data, in the metadata of these datasets, we will have a URL which points to a connector that can be used to consume data from that dataset. So let's just take this URL, put it into the user interface of our connector, try to fetch datasets there. This will give us a list of datasets, hopefully. Yes, if we look at the representations for this dataset, we will see that we only have one. If we look at the artifacts for that representation, we will see that we only have this one. Now, if we want to interact with this artifact, we will have to accept the usage policy set by the dataset owner. So let's just accept that. That's basically negotiating a contract, and then we will have a URL to interact with the artifact, including download its content. For this last step, I will switch to Postman, as this web interface is not really able to reference the agreed contract. So if we switch to the Postman, we can do the exact same steps. Interesting for us will be the last one, so let's just run this. Run collection, not all, but instead let's just include these steps as shown on my screen, run them, and the last step should show us the content of the artifact, which is this one, and the response body is the content of the artifact.
In this step, we'll demonstrate how IMT discovers datasets in the global catalog using Catalogue Manager, but not only consumes data from one of them, but also transform data using a local data app.
In this part of the demo, IMT will also show retrieval of data from the dataset published by ITI. But in addition to what was already demonstrated, we will also show how to further process the retrieved data using a data app registered in the App Store of our local dataspace connector. The output of the data app will be an AI model, and we will use Postman to make requests to our local connector. First, let's list the datasets in our local connector to show that we have none. Then, we will fetch the details of a dataset available on our remote ITI connector. For this, we will pass along some parameters. The URL to the remote connector we got from the federated catalog, the ID of the catalog in which the dataset is published, and the ID of the dataset itself. This, of course, means we already know these IDs. In case we don't, we can use the discovery steps e.g. I demonstrated earlier. When we make the request, we get the metadata about the dataset. You can see that we already made an agreement for the artifact in the dataset before this call. Having already accepted the usage policy set by ITI for this artifact, we can make the next request to retrieve the data of the artifact, and we can see it's a CSV file. This also caused our local connector to cache a local copy of this artifact. We will use this CSV file and feed it to a local data app. We can list the data apps registered with our local connector and see that we only have one, named KMIS. Looking at the details of this data app, we can see that the Docker image that is used to publish the data app container, the parameters expected to be passed using environment variables, and that the input is a CSV file. Now, running the data app on the dataset, we have to pass along the parameters expected by the data app, in this case, the number of clusters, and the ID of the dataset on which to run it. When we execute the request to actually run the data app, we can see some results of executing this query, but also that the data app was started successfully. We can then use this to run some Python AI code, or we can even publish it as part of a new dataset that we can then share with the Federation using the Catalogue Manager. In summary, our hope is that we demonstrated how datasets can be shared, discovered, consumed, and further processed by all the IHs in the EU Hubs for Data Federation in a secure data ecosystem of trusted partners and where data access policies are enforced. Thank you for your attention.